Now again, the first thing we're going to need is that Pascal's triangle. So either you memorize what's on the fifth row, or you rewrite it as you need it. So we start at the top at 1, 1, 1, 1, 2, and we always add the two numbers together as we work our way down the triangle. So 1, 3, 3, 1, that's the third row, fourth row, and finally the fifth row. Now I open with this example partially because this is not one we can be even tempted to try to do by brute force. Taking x minus 3 and multiplying it by itself 5 times is going to take a long time. And so I wanted to remove that opportunity for us to say, hey, let's not bother with this here. This is one you really have to do with binomial expansion. So we said the first thing we're going to do is we're going to use these coefficients in my answer. So I'm going to have 1, 5, and I want a little more room. 10, 10, 5, and 1. So there would be my coefficients. I'm going to take the x term, which is like my a from what we were talking about. I'm going to start off with, I want to do x to the fifth, x to the fourth, x to the third, x squared, x to the first, and x to the 0 is just 1, right? Okay, so I won't write it. But I'm going to make a little 1 there so I remember. I'll make a note to myself, that was x to the 0. Don't forget this is x to the first. Okay. All right. Let's back up and find you then. For the binomial expansion, taking x minus 3 to the fifth, step 1, go to the fifth row of Pascal's triangle. How do you draw the triangle? You start off at 1, 1, 1. Then you add the two numbers above to get each new number. So it always will look like that. Those numbers, that is Pascal's triangle. There's some really neat stuff as you go down to like row 385. Neat patterns start to emerge. We're not going to go that far.
For this time, this triangle is 1, 4, 6, 4, 1.
Yes, that's right here. 1, 4, 6, 4, 1.
When does it change?
We go to the fifth row because it's to the fifth power. What's up? Why do we do that? Which why? Why am I using Pascal's triangle? Why am I using the fifth row?
The triangle.
We're using Pascal's triangle because that pattern of numbers will always give us the coefficients when I do this expansion. It always works out that way. You can always brute force it. That means you actually write x minus 3 times x minus 3 5 times and start foiling until the cows come home.
That's the only one.
That's the only other option. Fifth. Which also, you also have this. Oops, I don't want blue highlighter though. Yellow. Thank you. Right there, that 5 matches that 5. So that's the row I'm going to use.
Why'd you write 1 at the very end?
Because that's x to the 0.
It's not x to 0, is not 1.
X to the 0 is 1. Any number to the 0 is 1. Right?
What's to the 0 then?
Anything to the 0 is 1.
Which one is the answer that gives you 0?
Nothing to an exponent except 0 will give you 0. 0 to any power is 0, but to get to 1, that would be something to the 0 power. So then what I'm doing for this, I'll kind of go back a bit and find you guys. I'm writing, did it again. I want my pen, not my highlighter. So these numbers in black are the coefficients that come off Pascal's triangle. The x's in red are the first term x going down by my exponents. 5, 4, 3, 2, 1, nothing. The nice thing about this algorithm is it follows this pattern. And it's a lot faster once you get the pattern down than, again, brute force. Now I'm going to take the second guy, -3. I'm going to count him up. So I'm going to do -3 to the 0, -3 to the first, -3 squared, -3 to the third, -3 to the fourth, and finally, -3 to the fifth. So notice the x's go down as the -3's go up. Where did I get what?
Y is -3.
Y negative 3, because it's the second number.
And Y is 0.
Why is it 0? Because I start at 0 and I count up. See, the x's, the first term, I started at 5, which is the exponent attached, and I counted down. So here's my x. So I started at the 5 because it's fifth power, and I counted down 5, 4, 3, 2, 1.
But there's 6 rows for that triangle.
Yeah.
But there's not 6 terms.
Well, let's see. I used 1, 2, 3, 4, 5, 6 numbers. Row 5 of Pascal's triangle has 6 numbers.
The exponent's not 6.
That's okay. The fifth row, actually, the way we number them, that starts at row 0. Row 1, row 2, row 3, row 4, row 5. Yeah. Think of it this way. This doesn't count as a row. It counts as the peak. There we go. And then, well, because it's our first time through, of course it's going to take a little longer. Everyone's got to figure out what's going on. That's okay. And now all I have to do is simplify what I see in front of me. Which, now granted, that might also still be kind of hard, but all I'm doing now is cleaning up each term. The other nice thing is none of these terms will combine when I'm finished. This will be in standard form, and it will be completely reduced, and all like terms will be combined. So like this first guy, 1x to the 5th times a number to the 0, that's just x to the 5th, isn't it? All right, let's come over here. I've got x to the 4th. All right, that's not going to change. Negative 3 to the 1st is negative 3 times 5 is negative 15. Negative 3 is negative 3 to the 1st. And then here's the 5. And that gives me 15.
Why don't you go 5 times in this?
I could. You'd still get negative 15. All right, next term up. Let's see. I've got 10. Let's see. Negative 3 squared is a positive 9, right? So that gives me 90x to the 3rd. Now, I'm not adding anybody because all the x's have different exponents. It is. Negative 3 times negative 3 is positive 9.
And for that one, but you're only -3.
Oh, you mean for this term here, the second term?
Yeah.
Well, negative 3 to the 1st is negative 3.
Oh,
And 5, yeah, all right.
okay.
And then next up, let's see, negative 3 to the 3rd, it's negative 27, isn't it?
Yeah.
And then 10. So that gives me minus 270x squared. And again, that x squared doesn't change any. Almost there. We got 2 terms to go. Let's see, negative 3 to the 4th. Now things do start to get kind of weird. That's 81. So 5 times x times 81. 5 times 81 is going to give me 405. And then my last one, 1 times negative 3 to the 5th. Round out on my head. 243? No. That's negative 243. That sounds right. There. And now we're done. Now, in fairness, first time through is going to feel a little rougher than once you get the patterns down. Once you got the patterns, it's going to go quick.